First thing we have to be aware of when we're talking about angles is that we're going to be putting them on a coordinate plane. And that coordinate plane has something, we have a way of organizing them so that they're in something called standard position. Okay? So whenever we talk about an angle is made up, if you remember back from geometry, of two rays. Okay? We call the ray that's on the x-axis, the positive x-axis, the initial side. And the ray that is swung from that positive x-axis, the terminal side. Okay? Initial side, terminal side, if it's an acute angle, that's what an acute angle looks like on the coordinate plane. Initial side, terminal side, if it's an obtuse angle. Okay? And the origin, 0, 0, is called the vertex of that angle. So far, so good? Okay? So this is what I'd write down on your foldable, something of this nature. If we fix one ray called the initial side, you don't have to write it in all these words, okay? Initial side on positive x-axis is how I would write it. Less writing. And rotate the other ray of the angle. So you can say other ray called terminal side. Then it's in standard position. Just some vocab we have to throw at you first. So to abbreviate these notes, just say the initial side is on the positive x-axis. The other ray, called the terminal side, and then it's in standard position when we have the initial ray on the positive x-axis. How many degrees are there in a full circle? 360. So if we rotate all the way around from our initial position all the way around, that's 360 degrees. What's half of a circle? 180. So if we only do half of a revolution, then we've done a 180. We're going in the opposite direction that we started in. Okay? A fourth of a revolution is 90 degrees. 3/4 of a revolution is 270 degrees. Okay? Some of you still writing, so I'll wait just a moment. Okay, ready? All right. So let's draw some angles in standard position. Okay, when you do that, you simply make a big T, right, for the positive or for the x and y axes. Okay, and if it helps you to put x and y here, feel free. My initial ray is always, always, always at the positive x-axis. Okay, how far does it have to go to get to 135, roughly? It'll be an obtuse angle, very good. So it's between 0 and 180. So it's going to be over here in the second quadrant. This is quadrant 1, and this is quadrant 2. So it will be over here somewhere. Okay. How far will it be? Will it be closer to 90 or closer to 180 or halfway in between? Potentially closer to 90. What is 135 minus 90? 45. So is it closer to 90 or closer to 180? Or halfway in between? Halfway in between, right? Okay, so it's going to be a little halfway in between guy. And then we just draw a little arrow to say, hey, this is how far we rotated. We took our terminal ray and we rotated it 135 degrees. Okay. Well, you knew it was supposed to be in the obtuse, right? Okay. So if we want to see how close we need to be to 180, we take 180 minus 135. If we want to see how close it should be to 90, we can take 135 minus 90. Either way, it'll kind of give us an idea. And I'm not going to expect you to use a protractor to get it perfectly dead on, just something that looks reasonably close. Okay? Mine's not close, not quite there, is it? That doesn't look like exactly halfway between these two. I look like I'm closer to 180 than 90. Okay? So I'm not expecting perfection, just a general ballpark here. Okay? So far so good? All right. Well, what would a negative 160 be? Very, very good. Veronica's got great instincts. She thinks instead of going to the in a counterclockwise method, that we need to go in a clockwise method, and she's exactly right. Okay, this is a positive 135 degrees because we went in the counterclockwise direction. Okay, a negative 160 degrees says we're going to go the opposite way, clockwise. Okay, so what kind of an angle is 160? Obtuse again, right? So we need to be bigger than 90, but less than 180. Is it going to be closer to 90 or 180? 180. In fact, it'll be 20 degrees short of 180, right? So we draw something that looks like it's about 20 degrees short of 180, and we call this guy negative 160. Didn't write that very well. Erase and try again. Okay. Now we're ready for letter C. 300 degrees. Never dealt with 300 degrees before, did we? Okay. So how big is 300 degrees? That's more than obtuse, isn't it? Start at your initial ray, okay? And we're going to go a long ways around, aren't we? 60 degrees short of 300. Very good. So this is going to be 60 degrees short of 360. So this is going to be 300 degrees. And again, I just want a ballpark idea of where you're at. Not expecting a protractor out for this. Okay? Now they throw something even crazier at us. 390 degrees. Very good, Manny. Go all the way around and then come back up into that first quadrant again, right? Okay? Because we're starting out here and positive directions this way. If I go one full circle, I'm at 360 degrees. But I've got to go further, right? How much further? 30 degrees more. So we're going to be right about there. And we call that a positive 390 degrees. Yes, sir. It's the same as a 30-degree angle. Absolutely. Okay. Does that make sense? And we're going to talk about them in just a moment. Things that are coterminal, things that have the same terminal ray. Okay. Very good. Same thing as a 30-degree angle. Next one, 690. Okay. We know we've got to go all the way around at least once, right? 30 degrees shy of 720. Jordan could look at that and say, I'm going to be in the 4th quadrant, which means that he's got great instincts. Going to be 30 degrees shy of 720. 720 is 2 complete revolutions, isn't it? So there's our initial ray and there's our terminal ray. Counterclockwise for positive, as many loops as you need to make it happen. Okay, so I'll be looking for the spirals and then a general idea of where you should be. Okay? Awesome. Next one. Special angles. So I came up during break. I took some time to make some spinners for you. This was during Christmas break, so while you were all sleeping in, I was up here using the copy machine and finding cardstock. Get a mix of colors going here. Making hole punches. So you can put your name on this. This is yours to keep. Extra one, I didn't count right, thank you. And then you want to orient them so that the Y is on the top and the X is to the right. And we'll work our way around these special angles. Okay? So we'll start with what we know. We just talked about 0 degrees being at the start. Our initial ray is always at 0 degrees. Okay? What kind of special angles do you think we're talking about here? The special named ones, the special triangles. Which ones did we have a table about on our last foldable? The 30, 60, 90s and the 45, 45, 90s. Okay, so we want to know about those special angles. So what kind of an angle do you think this one is? Definitely acute. And we've got a special dot here for this. How many degrees do you think that is? Because we've got another one here and another one here. So definitely the first one's the smallest, that's the medium size, and that's the largest one, right? So 30, 60, 30, 60, and 45, which one do you think this one is? 30. Yep, that's your 30-degree angle. So you can write your 30 here, or you can write 30 degrees out here. It does not matter to me. Okay? What's the next one going to be? Not quite 60. Next one before that, before 60? So 30, 60, 90, and 45. So we've got a 45 here. Might be easiest just to write them out here by the dots. Okay, and how about that one? 60. Okay. Now, if you start with this as your initial side and your terminal ray is this one, how many degrees is this? 90. Okay. Then we go a little bit further. What kind of an angle would this be if I went from here to here? Someone said it? Obtuse, exactly. Okay, it's going to be an obtuse angle. And there's another obtuse angle, and there's another obtuse angle. Okay? How much further from 90 do you think this one is? 30 degrees. Looks like the same angle as that, right? So 90 plus 30 is 120. This is 120 degrees. Okay? This is our 45 again. So what's 90 plus 45? 135. That was that one that we had that was exactly in the middle of 90 and 180, right? On the last slide. And this is 60 more than 90. So how much is it? 150. Okay. Half of a rotation is always 180. Okay. Now we're ready for the next one. This guy is how much more than 180? 30. So 180 plus 30, 210. Okay. 180 plus 45, 225. And 180 plus 60, 240. Okay. 3/4 of a revolution is how many degrees? 270. And so 30 more than 270, 300. 45 more than 270, 315. And 60 more than 270, 330. The spinner can help you orient things, figure out where things are. Okay. Everybody good? All right. So finding coterminal angles. Okay. Jordan already alluded to this when he said, hey, that 390-degree angle is the same thing as that 30-degree angle we saw earlier. Okay. Coterminal angles have the same terminal side. So to find them, we just keep adding revolutions or taking away revolutions, adding 360 or subtracting 360, and we've got coterminal angles. Okay. So again, only write what's necessary. You don't have to copy this whole slide, but angles are coterminal if they have the same terminal side. Co means together, so they have the same terminal side together. You can find coterminal angles by adding or subtracting 360. There's your key important piece. That's going to help you. Coterminal, same terminal side. Add 360 or subtract 360. So if we want to find a positive coterminal angle and a negative coterminal angle with negative 75 degrees, good old calculator. 360 plus negative 75 is how much? 285? And then 360, or negative 75 minus 360? Negative 435. So those will be easy points, right? Provided you have a calculator and you remember that we just need to add a revolution or take away a revolution, and a revolution is 360. Okay. What about 460? 100. Okay. So we could take away 360 from it and still have a positive one, right? If someone had added 360 to it and gotten 820, would that be an okay answer? Yeah, it's a positive coterminal angle with 460. So I'll be looking for multiples. It doesn't have to be 100, but 100 makes sense. This is what I would have done. Take away 360 because it was already bigger than 360. Now take away 360 again, and what do we get? negative 260, or 160, right? Take away 360, negative 260. If someone had taken 720 away from it, we'd have an even smaller negative number. And that's okay too, as long as they're full revolutions. Everybody good with these? Okay. All right, now we get to talk about radian measure. So a radian measure, we have a circle with radius of r, and we take that radius and we wrap it around the arc of that circle. That's 1 radian. The radius and the arc are the same distance. Then we have 2 radians, 3 radians, just a little bit more than 3 radians here. 3.141596 and so forth is pi radians. So half of a circle is pi radians. So a whole circle is going to be 2 pi radians. Does that make sense? Okay. I'll show you again. Take any old circle of radius r, and when we wrap that radius around the arc, around the outside of that circle, the angle formed by that radius's arc is called 1 radian. Okay? Just a little bit more than 3 radians in a semicircle, in a half circle. In fact, it's pi radians. That's where pi comes from, 3.1415, etc. Okay? And that means that there are 2 pi radians in the whole circle. Okay? So, if we want to convert between degrees and radians, we can use the conversion factor that there are pi radians in 180 degrees, or there are 180 degrees in pi radians. We have degrees, we'll multiply by pi over 180 to make the degrees go away. If we have radians, we'll multiply by 180 over pi to make the radians go away. And pi may or may not be might already be multiplied in. Okay? So that's going to be your conversion factor. So on the bottom left, or bottom left of your foldable, converting between degrees and radians, you multiply the degree measure by pi over 180. And in the block that's next to it, radians to degrees, you multiply the radian measure by 180 over pi. Everybody good so far? All right, let's look at an example, and then we'll have to table this for tomorrow. Okay? So, actually, I think we have just enough time to get our radians in here. Okay? So, on your unit circle, okay, you've got all this here, right? Okay? Let's do a couple of these. If I wanted to get from 30 degrees to radians, I'm going to take my 30 degrees, and I'm going to multiply by what? Pi over 180. Yeah, we'll just do this one and we'll be done because the bells, we have a minute till bell. So the degrees are going to cancel, and 30 over 180, the zeros cancel, right? And 3/18 reduces to what? Three-eighteenths reduces to, both have a 3 in common. I'm hearing people say 6, 1/6, right? So this will be pi over 6. And we'll come back and talk about this tomorrow. Okay? So no assignment today, just review your foldables so that you've got them familiar and comfortable and confident. Okay? You don't have to do the student journal. Okay. Actually, it may not hurt to do. It may not hurt to do just the you won't be able to do all of it, but I think you could actually do the terminal sides. But we'll come back. Okay. You did. Give me 1 second to finish recording here.